This is the second in the series of 3 videos on calculating the area under a curve. In this video I will explain how to calculate areas that lie below the x-axis. Now consider the area enclosed by the curve y equals x plus 1, x minus 2 and the lines x equals 0 and x equals 2. Now by using the formula, the area equals the integral from 0 to 2 of x plus 1 x minus 2 dx, and expanding the brackets, the area equals 0 to 2 x squared minus x minus 2 dx. Integrating, we get the area is equal to x squared integrates to x cubed over 3, x integrates to x squared over 2, and minus 2 integrates to minus 2x between 0 and 2. We substitute the limits and the area equals 8 over 3 minus 2 minus 4 minus 0, and that becomes minus 10 over 3, which is negative. So what does that mean? Well, let's sketch the curve. So y equals x plus 1 x minus 2 is a quadratic, so that's a parabola, and we can see that it crosses the x-axis at minus 1 and 2, and like that, where we have minus 1, 2 and minus 2 on the y-axis. So the area between 0 and 2 is this, and the curve is this area here, which we can see is below the x-axis. Now remember that area is the sum of the strips like this that we divide the area into. So it's the sum of rectangles, and so the rectangle's area was y delta x. And we can see if the strips are below the x-axis, the y value would be negative. And so the sum of the y dx, because dx is positive, the sum of that would also be negative, and so we get a negative area. However, the actual area is still a positive value, and it is the positive value of the integral. So in this case, minus 10 over 3 is the value of the integral, but the area itself is 10 over 3. Now let's consider the area enclosed by y equals x plus 1 x minus 2 again, but this time the line between the lines x equals 0 and x equals 3. We sketch the curve again, and the area this time though is between 0 and 3, which is there. So the area we need to calculate is that. The area is in 2 parts. We have A1, this area below the x-axis, and A2 between x equals 2 and x equals 3 above x-axis. Now we know A1 already. A1 is equal to 10 over 3 from the previous problem. So A2 is the integral from 2 to 3 of x plus 1 x minus 2 dx, and as before, A2 is the x cubed over 3 minus x squared over 2 minus 2x between 2 and 3, and evaluating at 3 and 2 comes to 9 minus 9 over 2 minus 6 minus 8 over 3 minus 2 minus 4, which comes to 11 over 6. So the total area, and that is A1 plus A2, which is 10 over 3 plus 11 over 6, which is 20 over 6 plus 11 over 6, 31 over 6 square units. Now you see, it wouldn't have been possible to integrate the function between 0 and 3, because by doing that the area below the x-axis would be negative, and you'd add that to the positive value of A2, the area above the x-axis, given an incorrect answer. Why it is important always to sketch the curve before finding the area. Now pause the video and try this problem yourself. First of all, we need to sketch the curve. Now this is y equals x into x plus 1 squared is a cubic. It will have this general shape because it will have x cubed. The x cubed coefficient will be positive, and we can see there is a turning point on the x-axis at x equals minus 1, and it also passes through the origin where x equals 0. And so this is the sketch of the curve. So now the area is between x is equal to minus 1, well that is minus 1 there, and x is equal to plus 1 there, and so we need this area here, and we can see that part of the area is below the x-axis, which we'll call A1 here, and part is above the x-axis, which we'll call A2. A1 then is the integral from minus 1 to 0 of x plus 1 squared dx. But of course that's going to have a negative value, so the area itself would minus the value we get from that, which will turn it into a positive value. So A1 is going to be equal to minus the integral minus 1 to 0. Now we need to expand the bracket. X plus 1 squared is x squared plus 2x plus 1, and multiplied by x we get x cubed plus 2x squared plus x dx. Integrating, this will equal x to the power of 4 over 4 plus 2x cubed over 3 plus x squared over 2, and we're evaluating between minus 1 and 0, equals minus, if x is 0 we have 0, and when x is minus 1 we have a quarter minus 2/3 plus a half, like that, and that will equal minus a 12th, which is a 12th. A2 is the area between 0 and 1, which is a positive area, so we just need to integrate directly from 0 to 1. So A2 equals the integral from 0 to 1 of x plus 1 squared dx. That integrates to the same function as before, x squared over 2 from 0 to 1, and when we evaluate that we get a quarter plus 2/3 plus a half minus 0, and that equals 17 over 12. So the total area is equal to 1/12 plus 17 over 12, which is 18 over 12, or 3 over 2 square units. This is the end of the second video on calculating the area under a curve. In the third video I will be explaining how to calculate the area between a curve and a line.